The last speaker of this session is Kaarina Kauhala from the Finnish Natural Resource Institute here in Helsinki. She's a biologist and has specialized in carnivores and especially raccoon dog. And you are going to talk about diseases and especially parasitic diseases in this species.
Thank you. So good day for everyone. I will talk to you about the raccoon dog, the invasive raccoon dog as a vector of diseases and parasites in the wildlife community. How does it work? Okay. So, earlier in Europe, the red fox was the main vector of rabies, or wildlife rabies. But the role of the raccoon dog has greatly increased in recent decades. And in Finland, we had an epizootics of wildlife rabies in the late 80s, and the raccoon dog was then the main vector of the disease. About 75% of the observed cases were in raccoon dogs. Also in Estonia, the proportion and number of rabies cases in raccoon dogs increased in the early 2000s. And after 2002, the proportion of raccoon dog cases was greater than the proportion of fox cases, which declined. Rabies in raccoon dogs has also been found in Russia and in many Eastern European countries, including Belarus, Poland, and Ukraine. But today, as you just heard in the previous presentation, many European countries, and including Finland, are rabies-free due to these bait vaccinations. But rabies in both raccoon dogs and foxes still occurs in some East European countries. This is a map of the situation in Europe from 1990 to 2003. And here the figures, the first one refers to fox cases and the second one to raccoon dog cases. And you see that during the epizootics in Finland, we found 77 rabid raccoon dogs and only 19 foxes. And also in the Baltic states, the numbers of raccoon dog cases were quite high. But then in Western Europe, such as Germany, all cases which were found were in raccoon dogs, in foxes, because raccoon dogs were still quite scarce at that time. So we had a study in Virolahti in southeastern corner of Finland, where we wanted to study the possible contact rates between medium-sized carnivores which could transmit rabies. So we studied home ranges of these species, their contact rates, their nightly routes during certain nights. And we found that their home ranges overlapped largely, and also their nightly routes crossed each other. So contacts between them are very likely, and if one species has rabies, it's very likely that it transmits to the other species. This is an example of fox and raccoon dog home ranges which overlap almost totally. And here is the distance between them when they were located at the same time, so quite often quite near each other. And an example of the nightly routes which cross each other. The same figures of a badger and raccoon dog home ranges overlap, nightly routes cross each other. Here are two raccoon dogs and one badger, and here seems to be some kind of hotspot where all animals visited during the same night. And all the home ranges of badgers and raccoon dogs in the area, These bigger ones with dotted lines are badgers, and the small ones with solid lines are raccoon dogs. So you can imagine what happens if one of these has rabies. It's easily transmitted to the other species. And raccoon dogs and domestic cats also have overlapping home ranges, and their nightly routes cross. And here are also the home ranges of both species in the area, which all overlap very much. So there are frequent contacts between cats and raccoon dogs, and if cats roam out and meet raccoon dog which has rabies at night and then comes home, so it poses also a very high risk to humans. So largely based on these data, we built rabies models for a new situation in Europe with two main rabies vector species, the raccoon dog and the fox. The former rabies models were also based on solely fox rabies, because fox was the main vector in Europe for decades after the Second World War. But now there is a new situation in Europe with two main vector species. And the models showed that an epizootic with two vector species would be much stronger than the epizootic with only one vector species. And what is quite alarming is that an outbreak of rabies is likely when the pool density of the two vector species is lower than the threshold demanded for rabies with only one vector species. You just heard that the threshold density is about 1 case per square kilometer, but with two vector species, the pool density can be lower than that, and that's very serious. And the raccoon dog would be the main vector in areas such as southern Finland, where its density is high. And so the risk of epizootics is highest in autumn when the juveniles disperse. Foxes may also disperse in autumn, but in Finland some foxes disperse only after the Christmas time. But because raccoon dog was here, the main vector species, so the risk for epizootics is highest in autumn when raccoon dog juveniles disperse. The risk is lowest in winter when raccoon dogs hibernate, and also badgers hibernate because they can share the wintering dens. But this situation is also changing because climate is warming. Even at present, winters in the southern Finland can be very mild, only little snow, and we can see active raccoon dogs and even active badgers in midwinter. So the period of hibernation is shortening, and the risk for epizootics also in winter is increasing. Raccoon dog also hosts many parasites, such as Echinococcus multilocularis, called also fox tapeworm, or myra-echinococci in Finnish. Fox has been the major definite host of this parasite. Its intermediate hosts are small rodents. But recently, the prevalence in raccoon dogs has also been increasing in Europe. For instance, in northern Germany, it's between 6 and 12%, in Poland about 8%. And it's spreading northwards. At the moment, it's already common in Estonia. Prevalence is higher in foxes, but also quite high in raccoon dogs. Also in Sweden, some cases in foxes have been found. We don't so far have it in Finland, but of course we are afraid that it will come here too. Dogs can also spread it, and that's why dogs which go abroad and come back to Finland must be treated with a medicine to prevent the parasite coming to Finland. It's not dangerous to canids, but it can cause a fatal disease in humans if not treated in time. People may get it from parasite eggs, which are in the feces of canids. And if there are fox or raccoon dog feces in the forest, and then there are berries growing nearby, bilberries or lingonberries, for instance, there can be eggs on these berries. And that's why berries should be cooked in areas where this parasite occurs. The eggs are not killed in the freezer, so the berries must be cooked. Raccoon dogs also host other parasites, such as Trichinella species. Trichinellosis was found in Finland before 1950s only in imported pigs, not in wildlife. But the prevalence in wildlife increased after 1950s when raccoon dogs invaded the country. And raccoon dogs host all 4 Trichinella species, which are found in Finland. And furthermore, the prevalence in foxes is highest in areas where raccoon dog density is high. So all these point to the conclusion that raccoon dogs may be the main vector of trichinellosis in Finland. Sarcoptic mange is one disease, parasite, also which is common in both foxes and raccoon dogs in Finland. It causes a painful skin disease, and animals usually die of it, so it can be a very important mortality factor for foxes and raccoon dogs. Epizootics occur in dense populations, and the parasite may spread from one species to the other. And it's usually, the epizootics are quite local in one area, but then many animals die and the density decreases, and then it jumps to another area. A few words of supplemental feeding of wildlife, because these feeding sites may be very bad for disease transmission, because many species gather to the feeding sites, and for instance, medium-sized predators, and then they may have rabies, echinococcus, mange, and so on. This is from North America. There is a white-tailed deer feeding site, and there are 7 raccoons also eating there. In Finland, there could be 7 raccoon dogs and maybe some other species too. So, a few words of control pathogens. Pathogens are easily transmitted, and an outbreak of epizootic happens in a dense population. So, people usually think that, okay, we will hunt them so that the population density declines. But first, it's difficult because raccoon dogs increase their litter size when they are under a heavy hunting pressure. The litter size of raccoon dogs in southern Finland is usually between 9 and 10, but under a very high hunting pressure, it may be 12 or 13. So hunting should be so effective that in spite of the fact that it increases its litter size, the absolute number of pups produced would decline. And that's certainly very difficult. And second, diseases may spread faster in a sparse population due to longer dispersal distances. So hunting can even accelerate disease spread. Then these hotspots, such as the feeding sites for wildlife or other places where they forage, garbage dumps, fields, and so on, they can be very bad for disease spread. So feeding wildlife likely accelerates the spread of pathogens. And in many papers where people have compared the positive and negative effects of wildlife feeding, the conclusion is that do not feed. And last, a success story which you already heard in the previous presentation is the bait vaccinations for rabies. And during the epizootics in Europe after the Second World War, very many foxes were really killed, and as we saw, it was not effective. So only after the bait vaccination started, many European countries became rabies-free. The cases declined really sharply. So this is an effective method, and it's non-invasive method. In Finland, we use these baits with fish meal with vaccine distributed from an aircraft. We do the vaccinations once a year in autumn when raccoon dog juveniles disperse. And both raccoon dogs and foxes eat the baits. And when we had these epizootics in the late 80s, the first case was in April 88. And in autumn 88, we started these bait vaccinations. And the last case was in February 89 in a fox. So only after a few months after starting the vaccinations, Finland was rabies-free. And since then, we have been rabies-free, wildlife rabies. Thank you for your attention.
Thank you for the interesting presentation. I think we have time for a couple of questions. No, okay. Then I have one. I think it is very interesting what you said about the animals changing their behavior due to hunting. Are there other examples, or how should we take that into account? Because hunting is quite a common way of combating diseases.
Yes, but it's not a good way, as we have shown for rabies, for instance. Already very many foxes were hunted. The rabies spread with a constant rate of some tens of kilometers.
But there we had a vaccine. So.
Yes, it came later, but first we tried to eradicate, or in Europe people tried to eradicate rabies with hunting, and it didn't work. And it's because if an epizootic outbreak happens easily when the population density is high, but it may spread in a sparse population more rapidly. Because if you create empty places, so many juveniles disperse and they come to these empty places and take the disease with them to further. So the spread of diseases happens maybe faster when you hunt.
So this is an example of how biologists and veterinarians and people from agriculture should kind of cooperate to find solutions. Well, I want to thank all the speakers for this session. And now there is a 10 minutes break.
Please take some candies out there and stretch yourself a little bit.
Kiitos. Kiitos.